Take a look around you. Skyscrapers, satellites, plastic in the oceans, carbon dioxide in the air. Human civilization leaves marks everywhere. Now imagine this question. If all humans vanished today, how long would it take for Earth to forget we were ever here? A few thousand years? A million? 100 million? Earth is 4.5 billion years old. Human civilization is barely a blink. So here's the uncomfortable thought. If an advanced civilization existed long before us, would we even notice? In this video, we'll follow strange clues buried deep in rock layers, ice cores, and chemical signatures. We'll explore whether industrial societies could rise, collapse, and vanish almost completely. And we'll ask the big questions scientists are starting to take seriously. Are we really the first civilization on Earth, or just the latest? Earth is old, really old. So old that entire mountain ranges have risen, eroded, and disappeared again. So old that continents have smashed together and drifted apart like slow-motion bumper cars. Against that backdrop, modern human civilization is tiny. Agriculture began about 12,000 years ago. Industry took off just 200 years ago. On a geological timeline, that's not even a scratch. It's more like a fingerprint briefly touching wet cement. And yet, even in this short time, we've already changed the planet. We've altered the carbon cycle. We've scattered plastics across land and sea. We've left radioactive traces from nuclear tests that will linger for tens of thousands of years. These are not opinions. They're measurable facts written into Earth's layers. So here's the key idea. If we can leave a detectable signal in such a short time, what could an earlier civilization have left behind after millions of years? The problem is scale. Geological processes are incredibly good at erasing detail. Buildings crumble, metals corrode, cities sink, melt, or get subducted into Earth's mantle. But geology doesn't erase everything. It keeps summaries, thin layers, chemical anomalies, isotope ratios that don't quite make sense. Earth doesn't remember faces, but it remembers events. And that's where things start to get interesting. Because when scientists look closely at some of those ancient layers, they find signals that are hard to explain. Deep underground, far below any human-made structure, scientists have found something strange. Tiny metallic spheres, perfectly round, microscopic. At first glance, they don't seem special, but when researchers analyze them, the surprise appears. These spheres are rich in rare metals, the kind we associate with high-temperature industrial processes, the kind produced today by coal combustion, metal refining, and even nuclear detonations. Here's the problem. These spheres are embedded in rock layers that are millions of years old, long before humans learned to melt metal, long before cities, long before tools. In modern sediments, we know exactly where similar particles come from. Power plants, smelters, explosions. But these ancient versions predate everything we thought could produce them. So scientists ask the obvious question, could nature make them? In some cases, yes. Volcanic eruptions can form spherical droplets. Meteor impacts can melt material and spray it across the planet. But not all samples fit those explanations. Some appear in calm sedimentary layers, far from volcanoes, far from known impact events. On their own, these spheres don't prove anything extraordinary. Science doesn't work that way, but they open a door. Because once you accept that industrial-looking particles can survive for millions of years, a much bigger question follows. If an ancient civilization existed, its cities would be gone. Its machines would be dust. But its pollution, that might still be here. And that idea didn't come from science fiction. It came from geology. In 1980, a father and son team made a discovery that changed earth science forever. Walter Alvarez and his colleagues were studying a thin layer of clay found all over the world. Italy, Denmark, New Zealand, even the deep ocean floor. Everywhere they looked, the same layer appeared, always at the same point in time. And it contained something unusual, iridium. Iridium is rare on Earth's surface, but it's common in asteroids. The implication was shocking and elegant at the same time. 66 million years ago, a massive asteroid hit Earth. The impact spread iridium-rich dust across the entire planet. That dust settled into a thin, global layer, and right below it, dinosaurs. Right above it, no dinosaurs. One brief event, one clear geological fingerprint. This discovery proves something powerful. Earth records catastrophes remarkably well, even when everything else is erased, which leads to a provocative question. If a single asteroid impact can leave a planet-wide chemical signature, what kind of signature would an industrial civilization leave behind? Not buildings, not roads. Those are temporary, but altered chemistry, strange isotopes, sudden spikes in greenhouse gases, those can persist for millions of years. And once scientists started thinking this way, they realized something unsettling. There are other layers in Earth's history that look off. Abrupt changes, unexplained chemical shifts, signals that don't fit neatly into natural cycles. In 2018, two scientists asked a strange question. Not did ancient civilizations exist, but if they did, how would we know? They called it the Silurian hypothesis, named after a fictional ancient species from Doctor Who. Not because it was science fiction, but because the idea needed distance from preconceived assumptions. Imagine an industrial civilization that rose tens of millions of years ago. It built cities, used energy, changed its planet. Then it collapsed. Time did the rest. Plate tectonics crushed continents, erosion ground structures into dust, sediments buried the remains. After enough time, almost everything recognizable would vanish. So the scientists focused on what wouldn't vanish easily. Not artifacts, but planetary-scale side effects. Large carbon releases, synthetic chemicals that nature rarely produces, sudden climate shifts that don't match slow natural trends. In other words, the same kinds of fingerprints we're leaving today. The unsettling part wasn't that this idea was wild. It was that it was reasonable. Because when you zoom out far enough, Earth's history is full of sharp turns, long periods of stability, then abrupt change, which raises a dangerous assumption we often make, that every major shift must be natural. Volcanoes, asteroids, random chance. But what if that assumption is incomplete? What if somewhere deep in time, something else briefly joined the list of planetary forces? When scientists look at Earth's fossil record, they expect continuity, small changes, gradual transitions, one form slowly becoming another. And often that's exactly what they see. But there are moments where the pattern breaks. The most famous is the Cambrian explosion, around 540 million years ago. Before it, life was mostly simple, soft-bodied, hard to spot. Then in what geologically counts as a blink, complex animals appear. Eyes, jaws, armor. Entire body plans showing up almost at once. Not over hundreds of millions of years, but within a few tens of millions. That's fast, uncomfortably fast. Scientists have proposed many explanations: changes in oxygen levels, genetic innovations, environmental shifts. All reasonable, none fully satisfying. And the Cambrian explosion isn't unique. Throughout Earth's history, there are other moments where ecosystems seem to reset, disappear, reassemble in strange new ways. Often these transitions line up with massive geological events, volcanism, climate shifts, ocean chemistry changes. But here's the quiet question lurking beneath the data. Are we sure we know all the forces capable of reshaping life on a planetary scale? Because today, there is one force powerful enough to do it: us. Modern civilization moves carbon faster than volcanoes, alters ecosystems faster than evolution can adapt, creates compounds that didn't exist anywhere on Earth before we made them. If such a force existed once before, its direct traces might be gone, but its effects could still echo through the fossil record. Modern civilization doesn't just build things, it rewrites chemistry. Burning fossil fuels changes the balance of carbon isotopes in the air. Industrial nitrogen use alters soils worldwide. Plastics introduce long-chain molecules nature almost never makes on its own. These changes don't disappear when cities fall. They settle into ocean mud, into lake beds, into layers of rock that future geologists will read like pages in a book. Today, scientists already talk about the Anthropocene, a proposed geological epoch defined by human activity, not because of skyscrapers, but because of chemistry. Radioactive fallout from nuclear tests forms a global marker. Microplastics rain down everywhere, from mountaintops to deep sea trenches. Carbon isotope ratios have shifted in a way that stands out sharply from natural variation. Now stretch that idea across deep time. Imagine an ancient industrial society that lasted a few thousand years, geologically insignificant in duration, but chemically intense. Over millions of years, erosion would grind its cities away. Plate tectonics would recycle continents. But altered isotope ratios, sudden carbon spikes, unnatural compounds, those could survive as blurred but detectable signals. And here's where things get uncomfortable. Because Earth's history already contains several moments where the carbon cycle goes completely off the rails. About 252 million years ago, Earth almost lost everything. This event is known as the Permian-Triassic extinction, or more bluntly, the Great Dying. Around 90% of marine species vanished. On land, entire ecosystems collapsed. Life didn't just struggle, it nearly reset. The usual explanation points to massive volcanic eruptions in what is now Siberia. Lava floods, toxic gases, runaway warming, and yes, those eruptions were enormous. But when scientists look closely at the rocks from this time, they find something else too. A sharp spike in carbon, not just more carbon, but a specific type of carbon. One that suggests a sudden release from organic sources. The atmosphere changed faster than most natural systems comfortably allow. Oceans turned acidic. Oxygen levels dropped. Methane may have surged. This chemical chaos unfolded quickly, geologically speaking. Now, to be clear, volcanoes alone can do terrible things. No one disputes that. But the pattern is eerily familiar, because today we are triggering similar chemical shifts, only faster. We're releasing ancient carbon. We're warming the planet. We're stressing ecosystems at a pace evolution can't keep up with. So the question isn't, was the Great Dying artificial? It's subtler. If an industrial civilization existed before humans and it destabilized its planet, would the aftermath look very different from what we see here? After millions of years, intent disappears. Only consequences remain, and consequences don't come with labels. In the 1970s, scientists made a discovery that sounded impossible. In Gabon, West Africa, they found evidence of a natural nuclear reactor. 2 billion years ago, uranium-rich rock formations reached just the right conditions. Water acted as a moderator. Nuclear fission began and sustained itself for hundreds of thousands of years. No engineers, no machines, just physics doing its thing. This discovery was important for one reason above all. It proved that extraordinary phenomena don't automatically mean intelligence. Nature can surprise us, and that makes the search for ancient civilizations much harder. Because if nuclear reactions can happen naturally, then anomalous radiation alone isn't enough. If metal spheres can form in volcanoes, then melted material isn't proof either. Every strange signal has to be weighed carefully. But here's the flip side. The Oklo reactors also prove something else, that nuclear-scale processes can leave long-lasting, measurable signatures in rock. Isotope ratios altered in ways that persist for billions of years. So now the question shifts again. Not could nature do this, but would technology leave something nature almost never does? Patterns, consistency, global synchrony. Which brings us to another archive Earth keeps surprisingly well, one that records the atmosphere itself. If rocks are Earth's long-term memory, ice is its diary. In places like Antarctica and Greenland, snow falls year after year, compressing into ice. Tiny bubbles of air get trapped inside, and those bubbles are time capsules. They hold samples of ancient atmospheres. By drilling deep ice cores, scientists can read Earth's climate history year by year, stretching back hundreds of thousands of years. What they see is usually slow change. Carbon dioxide rises and falls with ice ages. Methane drifts up and down with natural cycles. Everything moves at a measured pace, until it doesn't. At several points in the record, greenhouse gases spike rapidly, not over hundreds of thousands of years, but over centuries, sometimes faster. The most dramatic example is today. Modern CO2 levels shoot upward like a wall. Nothing in the ice core record looks quite like it. But there are earlier moments that rhyme. Abrupt warming events, sudden methane releases, atmospheric shifts that strain natural explanations. Again, none of this proves ancient climate engineering. Volcanoes, ocean circulation changes, and feedback loops can cause chaos. But here's the uncomfortable parallel. If an industrial civilization tried to reshape its climate, intentionally or not, this is exactly where the evidence would appear. Not in ruins, not in tools, but in air chemistry frozen in ice. And if such a civilization collapsed, the climate system would eventually settle down again, leaving behind a spike, a scar, a question. Let's pull back. After all the layers, spikes, gaps, and strange signatures, one thing becomes clear. There is no solid evidence that an advanced civilization existed before humans. No confirmed machines, no unmistakable ruins, no smoking gun. But there is also something else. There is no law of nature that says it couldn't have happened. Earth is old enough, life has been complex long enough, and geology is ruthless enough to erase almost everything except chemistry and consequences. The most important insight from this whole question isn't about ancient aliens, lost continents, or forgotten empires. It's about us, because for the first time in Earth's history, a species has become a geological force on purpose. We know how to read extinction layers. We know how carbon spikes look in stone. We know what happens when planetary systems are pushed too far, which means we may be standing at a familiar point in a story we don't fully know. If there were others before us, their legacy isn't wisdom or technology, it's absence. And that absence carries a warning. Civilizations don't need enemies to end. They just need momentum without restraint. So the real question may not be, are we the first civilization on Earth? But this, will we be the first one to understand the consequences of existing at all and choose to last? Because millions of years from now, Earth will still be here. And whatever comes next will study our layer in the rock, the carbon spike, the plastics, the isotopes, and they'll ask the same question we're asking now. Were they just a brief experiment or the beginning of something that finally learned how to stay?